Adapter views are generic view groups that are used to display a list of data. Layouts are generic view groups that are used to organize and structure other views and view groups. For example, consider the linear layout. This view group holds a set of child views or view groups, but it arranges the children in a single row, either horizontally or vertically. Let's look at an example. Here's an application called UI Linear Layout. And what you see here is a set of colored boxes labeled red, green, blue, and yellow. And they're all laid out in a horizontal row. Under that, there's another set of boxes laid out vertically, and they're labeled row 1, row 2, row 3, and row 4. So let's look at the source code to see how that layout was actually created. Here's the UI layout application, and I'm going to go straight to the main.xml file where its layout is stored. In this file, you see that the entire layout is a linear layout. And that linear layout has two children, each of which is also a linear layout. Now, the outermost linear layout has a layout width and a layout height of match parent. And this means that it takes up all of the space of its parent, in this case, the entire application window. And you can also see that its orientation is vertical. And this means that the children will be laid out one on top of the other. Now, if we look at the first child linear layout, we see that its layout width is match parent, so it should be as wide as the parent, the outermost linear layout. Its layout height, however, is set to 0. It also has a layout weight of 1. And we'll see how these bits of information are used in a minute. The last thing to notice is that the orientation is horizontal. So the children of this linear layout will be laid out next to each other horizontally. Now, let's go to the second child of that outermost linear layout. And it again is also a linear layout. And this element has a layout width of match parent and a layout height of 0. Its layout weight, however, is 3, whereas that first child had a layout weight of 1. And these weights tell Android that the first child linear layout should get 1/4 of the space, while the second child gets the remaining 3/4. The second child also has an orientation of vertical rather than horizontal. The next layout is a relative layout. With a relative layout, child views are positioned relative to each other and to their parents, rather than in a fixed order as we saw with a linear layout. Here's the UI relative layout application. This application contains an edit text view and 2 buttons. Let's look at how we get that particular layout. Now here's the UI relative layout application, and let's open up the main.xml layout file. As you can see, we've got a relative layout as the outermost view group. Inside it, there are the elements that we saw on the screen, an edit text view and 2 buttons. And they're labeled OK and Cancel. And if we look more closely, we can see that the OK button should be aligned to the right of the parent. That's the relative layout. And below the edit text, which is designated by its ID entry. Now the Cancel button says that it should be aligned to the left of the OK button, and that its top should be aligned with the top of the OK button. So putting all those constraints together then, Android is able to come up with the layout that you saw when we ran the application. The next layout is a table layout. With a table layout, child views are arranged into rows and columns. Here I'll start up the UI table layout application. This application mimics an old text-based menu, which you see is laid out, one command per row, and within each row, the different pieces of information are laid out in columns. In the IDE, we can open up the layout file. And here we can see that the layout is a table layout, and that within the table layout, there are a number of table rows. Within each table row, there is a list of views, and these views are assumed to be in numerical column order. But if necessary, you can specify a layout column. For instance, this row has nothing in column 0. So we have to tell Android that the first row's text view should go in column 1, not in column 0. And you can also see that this text view specifies a gravity of right, which means that the view's text should be pushed to the right of the text view. The next layout is the grid view. Grid views arrange their children in a two-dimensional scrollable grid. So I'll start up the UI grid view application. This application reads in a bunch of images and then automatically lays them out in a rectangular grid. And when I click on any one of these images, another activity is started that displays that single image. Let's look at the source code now. So here I've got the UI grid view application open in the IDE. I'll open its main.xml layout file. And in that file, you see that there's a grid view element. In that element, I've specified some things such as the width of the columns and the amount of spacing to leave around each image. I also specify that the grid view is free to determine the number of columns to use. Now going to the source code, I'll open up the grid layout activity file. In there, you can see that I've specified a list of image resources that should be displayed by the grid view. Down in onCreate, I set the content view and then set the adapter, which is an instance of the image adapter class. Let's look at the image adapter class. First, image adapter is a subclass of base adapter, which ultimately implements the adapter interface. This class has several methods that get used when the grid view is asking for data and for data views. Let's go through a few of this class's methods. First, there's the getCount method. This method should return the number of data items managed by the adapter. Another method is getItemID, and this returns an ID for the data item at a specified position. And this gets used, for instance, when the user clicks on an image in the grid view to indicate which image to load when the larger individual view pops up. The last method I'll talk about is getView. This method gets called when grid view asks the adapter for one view that will go into the grid. One of the parameters for this method is a view called convertView. And this parameter will sometimes be null. If so, then you need to create a new view and configure it however you want. But other times, convertView will not be null. It will actually reference a view that was already returned by this method in the past. For example, if you have a lot of views in the grid, then only some of them might be visible at any one time. So GridView will only ask for the views that it's going to display. But if the user later scrolls the grid view, some of the views that were visible are going to become invisible because they scroll off the screen. So Android will try to reuse those views, and it will pass one of those new views off to the adapter to get to the getView method. And then you'll just use that view and reset whatever fields that you need for your current data item. And this is good because it saves the time needed to allocate new views, which in turn can make the scrolling look much more fluid. The next thing I'll talk about are menus and the action bar. Activities can support menus. Menus can be presented to the user in different ways, but the basic idea is that menus give users a quick way to access important functions. So activities can add items to a menu, and they can respond when the user invokes the menu item, say by clicking on it. Now, the appearance of menus has changed in Android over time. So I'll talk about the basic menus first, and then later I'll talk specifically about the newer action bar class. Now, there are three kinds of Android menus. First, there are options menus, which are shown when the user presses a menu button. Older Android devices usually had a dedicated physical menu key. Newer ones don't. Second, there are context menus, and these menus are attached to specific views and are shown only when the user presses and holds that view. Context menus are usually used for operating on the specific data held in the view, while option menus and submenus tend to be for global operations that affect the whole application. And third, there are submenus. And these are secondary menus that are only activated when the user touches an already visible menu item. Let's look at some examples of these. So here's the phone application. Let me show you an example of an options menu for this application. First, I'll scroll over to the Contacts tab, and you can see that there's an icon here at the bottom. And when I click on it, a menu pops up, allowing me to do things like specify which contacts to display or import or export contacts. Next, let's see an example of a context menu. I'll open the browser application and use an options menu to get to the bookmarks functionality. Now that brings up a tab showing bookmarks, history, and saved pages. I'll select History, which shows me a list of web pages that I've visited recently. And now I'll press and hold on one of these web page history entries. And as you can see, that brings up a new menu supporting actions that can be applied to this one web page link. Things like opening it, bookmarking it, or sharing it. And last, let me show you an example of a submenu. Here I'll open the Gallery application, which shows me some photo albums stored on my device. I'll click on one, and now I see a photo from the album. I'll click on the menu icon, which presents a set of actions that I can perform. I'll select the Delete menu option. Now this brings up a secondary menu, which actually gets shown as a kind of dialogue in this case, asking me to confirm the deletion. Now in order to create the menus, you first define the contents of the menu in an XML file in the res/menu directory. When the user later opens the menu, Android calls a particular method, such as onCreateOptionsMenu for options menus and their submenus, or onCreateContextMenu for context menus. In these methods, you'll use a menu inflator to create the actual menu layout. When the user later selects one of the menu items, Android will call a method such as onOptionsMenu_item_selected for options menus and submenus, or onContextMenu_item_selected for context menus. Let's look at a simple example with all these different kinds of menus. This application is called Hello Android with Menus. I'll start it up, and as you can see, there's a text view, with the words Hello Android. And if I press and hold this text view, a context menu will pop up. And this one simply tells me to hit the menu button instead. So let's try that. Now, if you look up in the top right corner, you can see the icon that gets you to the menu items. And I'm calling that icon a menu button, but actually it's an overflow area for actions that appear on the action bar, which is the area at the top of the application. So let me click on that icon, and this brings up a menu with 3 entries: help, more help, and still more help. And if I click on these, some actions will be taken. Now for the first 2 menu entries, I just display some text on the screen. The last one, however, is associated with a submenu, which in this case just has 1 entry telling me there is no more help. Let's look at how this is implemented in the source code. Now here we are in the IDE, and I'll open up the Hello Android with Menu activity file. And first, we'll look at the onCreate options menu method. In this method, we get the menu inflator and then call its inflate method, passing in a reference to the menu layout and passing in the menu in which we want to put the new layout. Now I'll open the menu file top_menu.xml, and this file contains a menu tag, and inside it there are several item tags. In each tag there are attributes such as an ID, an icon to display for this item, and a title for this item. The third menu item also includes a submenu, which is specified by the nested menu tag. Back in the activity, in the last line of onCreate options menu, we return the value true, indicating that we want to display this menu item now. Now when the user selects one of these menu items, Android will call onOptionsItemSelected, passing in the selected item. Here, we check the item's ID and then take the appropriate action for that item. Now let's look at how the context menu is set up. First, when the user invokes the context menu for the first time, Android calls onCreate context menu. The code is very similar to what we saw with the options menu. You get the menu inflator, and you use it to inflate an XML layout file. Let's open it up. Now this menu just has a single item with the ID help_guide.